Hello, another question on compound interest. One of the key things we aim for as mathematicians is to try as much as possible to generalize what we're doing. And here we're just asking in general, how long would it take a debt of any amount to triple at a compound interest of 28%? After year one, that debt will be, let's call it x. It'll be x times 1 added to 28%. Or we can write 1.28 times x, or 1.28x. Year 2, after year 2, the debt will be 1.28 squared times x. Year 3, the debt will be 1.28 cube times x. After year 4, the debt will be 1.28 to the 4th power times x, the debt amount. Now, if we check what 1.28 raised to the 4th power gives us 2.68. So we're still not, we haven't tripled yet. But after year 5, we have 1.28 raised to the 5th times the debt of x. And that 1.28 raised to the 5th power is the same as 3.43 times x. And so we've answered our question. After 5 years, the debt would have tripled, in fact more than tripled in 5 years. So the debt will be more than 3 times after 5 years. We also can see a pattern here. If we start off here with finding out what our multiplying factor is, which is 0.28, we add that to 1 to get 1.28, and the power represents the years. You can see 3, so we can have that it's 1 add whatever percentage of compound interest. Let's write that as a word. Add compound interest raised to the n years. Thanks for watching. My name is Alistair. Bye for now. Hello, how many years does a debt of 65,000 take to double at 42% compound interest? Let's take a look. After 1 year, what do we have? We have the 65,000, and we're going to multiply that by 1 at the 42%. So 1 takes care of the debt of 65,000, which is 100%, and we're adding 42 to that. So that's the multiplying factor, which we can write as 1.42 times 65,000. After 2 years, we have 65,000, and now we have 1.42, and that's times 1.42. Now this multiplying factor is 2.0164, or we can abbreviate it to 2.02 of 65,000. So we can conclude that after 2 years, the £65,000 will be more than doubled. So the debt of borrowing £65,000 will be more than doubled in just 2 years. This is very important information and knowledge to be aware of. Thanks for watching. I'm Alistair. Bye for now. Hello. A company borrows £80 million at 6% compound interest. It repays the debt after 3 years. How much interest did it pay? What is compound interest? Well, that's interest not only on the principal amount, in this case £80 million, but also on the interest. So compounded means to add to. So let's see what we have. At the end of the first year, we have 80 times 10 to the 6, that's 80 million. And we have the 6% interest of that 80 times 10 to the 6. And that gives us the amount that's 84.8 million. At the end of the second year, we have now 6% on this amount, which includes the interest and the principal amount. So it's 848. This gives us this amount. At the end of the third year, we have this amount to look at as our new value. And we had 6% on this amount. I think I left out an 8 here. Giving us a final value of 9528. 1280. Now this is the amount we'll have, the company has to repay in terms of the debt after 3 years. Now we have to find out how much interest did it pay. Well, it borrowed 80 million, so we'll take away that from this final amount. This leaves us with 15,281,280 pounds. And that's the final result. Just recap what we've done. We borrowed, the company borrows 18 million and it's 6% compound interest. We also noted that compound interest is interest on the principal amount, in this case 80 million pounds, and also interest on the interest. After the first year, we add 6% to 80 million and we have a new amount. In the second year, that new amount, we add another 6%, and in the third year, for that new amount in the second year, another 6% is added. At the end of 3 years, the company has to repay 15,281,280. Thanks for watching. I'm Alistair. Bye for now. Hello. A car costs 60,000 a year ago. Now it costs, and we need to fill in here the blank, and they give us additional information that this is a 25% increase. Well, if it's increased by 25%, now 60,000 was equivalent to 100%, and if we increase it by 25%, then it's now worth 125%. Now the multiplying factor of 125% is simply 125 divided by 100, which gives us 1.25. So that's our multiplying factor. And if we want to increase 60,000 by 25%, we simply multiply 60,000 by 1.25, and that will give us 75,000. So with an increase a year later of 25%, the car costs now 75,000. What about if we now know that the car cost 60,000 a year ago and now it costs 80,000? How do we find out what the percentage increase? We know it's an increase because it's gone up by 20,000. One way of doing this is to find the percentage increase by dividing 80,000, what it costs now, by what it cost a year ago. These will go, all the zeros will go, and this will give us 4/3, which is the same as 1.3 occurring. How do we find the increase here? Now the 1 represents 100%, and the 0.3, which is recurring, is the 33.33%, because 0.3 occurring is equivalent to 33.33%. The fraction represented by 33.33% is 1/3, which is the same as 0.3 recurring. So our answer here is that it was increased by a third, which is 33.33%. Thanks for watching. My name is Alistair. Bye for now. Hello. An audience of 27,100 people attended a concert. 23% of the audience were male. How many males attended the concert? If 23% were male, we simply take 23% of 27,100. And this is the same as saying 23 over 100 times 27,100. Cancel that with that, and this will give us 23 times 271. By the way, I don't strike out the 1 here. It's the 2 zeros going with 2 zeros, which gives us a result of 6,233. Now part B, I didn't write it here, but part B is how many females attended the concert. There are two ways of doing it. You could find the percentage, which is 100% minus the 23%. So we know 77% of the audience were female. And then we can write that we find 77% of 27,100, which is the same as 77 over 100 times 27,100, which is equal to 208.67 females. Or we can simply subtract what we've just found. If we have that amount of males, we can just subtract it from the number of people in the audience, and this will give us the same result. So this males, females. Thanks for watching. I'm Alistair. Bye for now. Hello. My body is composed of 19 out of 20 of water, and my weight is 62.5 kilograms. How much of my weight is water? So when it says my body here, my body weight is composed of 19 out of 20 of water. What does this fraction represent? 19 out of 20, we can convert it to a percentage by multiplying by 100% to give us 19 times 5, which is 95%. So 95% of my body is water. My weight is 62.5 kilograms. So to find out how much water my body contains, I just have to find 95% of 62.5, which is the same as saying 0.95 times 62.5, which gives me 59.4 kilograms. What if I was asked the question, what percentage, or how many kilograms of my body is not water? Then if 95% is water, then the remaining 5% is not water. So from this, I can just find 5%, which is 5 over 100, of my body weight. And then I can find out what percentage of it is not water. This is the same as writing 0.05 times 62.5, which just gives me 3.12 kilograms. Thanks for watching. My name is Alistair. Bye for now. Hi, a car is advertised for £3,000. So let's make some notes. Advertised for £3,000. And it's to be sold next month. Tom can afford to pay £2,500. So Tom can pay just £2,500. That's all he can afford to pay. By what percentage will the price have to be reduced so that he can afford the car? Well, he needs a reduction of £500 because it's advertised for £3,000. He only has £2,500. So a difference he has to make up is £500. So they need to reduce the advertised price by £500. But what fraction does that represent, or what percentage does that represent of the original or the advertised price? Well, it's 500 over 3,000. Because it's selling for 3,000, you want to know what fraction or what percentage of it do you need to reduce in order for Tom to be able to afford it, and this is times 100%. And this will give us 1/6, 1 over 6, which is 16 2/3%. So advertised at £3,000, Tom can only afford 2,500, and so they need to reduce the price by £500, and that as a fraction of 3,000 is 16 2/3%. Here we have a diagram of a triangle that has been cut into a smaller triangle here and a trapezium. And we need to work out the area of the trapezium ABDE. So this shaded part here. And we're given some more measurements. We have this side here. We have the height here, and we're given this. We know these are also, we're given that these are right angles. So what springs to mind when you think about right angled triangles? We have no angles, so this must be a use of Pythagoras' theorem. So first we can go ahead and calculate maybe the area or the side. We can calculate the area of this triangle, but that might not help. But if we calculate the overall area of ACE, the triangle ACE, we should be able to find out what the area of the trapezium is. Well, let's take the first step. We do know that we can actually separate this diagram because we seem to have incomplete information. If we were to find the area of the trapezium, which is half the sum of the parallel sides times the height, we're missing the height. if we were to find the overall size or overall side of this large triangle, we're missing this distance or this length ED. So just like how when you were a kid you take things apart, it's no different in maths. This is how you discover what's going on. So we have the larger triangle. Let this represent the larger triangle. We have C, A, and E. We have 12 here centimeters. We don't have any other information, but on the smaller one we have a little bit more. We have the height at 8 centimeters, and this side here at 11. So we have C, B, and D here. Well, this brings to mind that both of these are right angle triangles. So we have a case of similar triangles here. Now they have their angles are proportionate and also their sides. So let's see what the scale factor is that will allow us to scale from the larger to the smaller. If you look at corresponding sides, we have 8 over 12, so a scale factor is 8 over 12, which is equal to 2 over 3. And we can check that. If we were to scale from 12 down to 8, we multiply by the scale factor, which is 12 times 2 is 24, divided by 3 will give us 8. So we'll be able to scale down. What else can we calculate from the information you've given? Well, we also know that this triangle, we can actually calculate the side BC, which is something we can use to find additional information. So we can use Pythagoras' theorem. So we have BC squared is equal to 8 squared add 11 squared. This is 64 add 121, which gives us 185. So BC must be the square root of 185. If I check this on my calculator, that gives us approximately 13.6 centimeters. Another approach we can take is to find the corresponding side DC on the larger triangle, which is EC. Now we're scaling here. This scale factor allows us to scale from the larger to the smaller. The opposite would be the scale factor 3 over 2, which is just by calculating from 12 over 8, which is 3 over 2. If we were to scale 8 up, we can see that would be 8 3 is 24 divided by 2, which is 12. So we can scale 11 to find this length. So that will be EC be equal to 11 times 3 over 2, which is equal to 33 over 2, which is 16.5 centimeters. So this length here is 16.5 centimeters. Now we have the height AE and we have the length EC. What can we calculate? Well, we can calculate the area of the large triangle, and then we can subtract the area of the small triangle, because we have the base, and we know our formula is half the base times the height. So for the larger triangle, area is half base times the height, is equal to a half of 16.5 times 12. That gives us 16.5 times 6. Let's check what that gives us. Which gives us 99 centimeters squared as the area. This is 99 centimeters squared. So that's squared, sorry. That's the area of the larger triangle ACE. Now the area of the smaller, so this is the large area of the small triangle, that's equal to half the base is 11 times its height, which is 8. So that's half of 88, which is 44 centimeters squared. So just to visualize what we've done, we've calculated the overall area here of this triangle, and then we also calculated the area of the smaller one, BCD. So if we were to remove this area unshaded from this larger area, we'll have the area ABDE, the area of the trapezium, and that's simply done by subtracting the area of larger, which is 99 centimeters squared, and we subtract 44 centimeters squared, which gives us 55 centimeters squared. Is there a way of checking this? Well, you could go about finding out what this length is, ED. We know the overall length is 16.5, and if this is 11, then the difference between them, which is 5.5 centimeters, will give you this length, ED. And then you can use that to calculate the area of the trapezium, which is half the sum of the parallel sides, and we can actually do this mentally. The parallel sides are 8 and 12, which is 20 centimeters. We've just calculated the difference between this length and this length to find that this is actually 5.5 centimeters. So we have the area is half the sum of the parallel sides. So if this is 20, then half of that is 10 times the height. The height here is 5.5 times height will give you 55 centimeters, which confirms that this is correct. So this was a problem of similar triangles. It's a good idea if you can understand this. This is what is called true problem solving. So first we found the overall size area of the larger triangle, and also we found a scale factor. Before that, we found the scale factors that would allow us to move from large to small or from small to large. We found the necessary sides of each triangle, and we're able to find areas of the large and small triangle and subtract the small from the large to get 55 centimeters square. Thanks for watching this video. My name is Alistair. Any questions are welcome, or comments. Please like, follow, or subscribe for more videos like this. Bye for now. Let's tackle this question. A 1-year-old car is worth £11,250. So £11,250. So it's just 1 year old. If its value had depreciated by 25%, so by 25%, in the first year, we need to calculate its price when new. So a year-old car, £11,250, is depreciated by 25. And we need to now calculate, and that's done in the first year, it's 25% depreciation. And we need to calculate its price when new. Now, what this tells us is that if it's depreciated by 25%, then this amount is equivalent to 75%. So this is 75%. Now we'd like to find what the new price is, and that would be when it's 100%. So we'll find for 1%, which means we divide 11,250 by 75, and we can do it in one sweep. So for 100% it would be 11,250 divided by 75 and then times 100. But a bit of, we can cancel here 25 threes, 25 fours, and this will work out to be 15,000 pounds. So when it was new, it cost 15,000 pounds. After a year's depreciation, it was down to 11,250 pounds. Here's the next problem. This year, a farmer's crop yielded. Here's another problem. This year, a farmer's crop yielded 50,000 tons. So we have 50,000 TON. So it produced that amount of whatever crop it was or product. If this represents 25%, so now this is 25%. Increase on last year, so this is a 25% increase on last year. So right away we can see that this value of 50,000 represents 125%, because if we increase by 25%, we're actually increasing from 100% to 125. So the question is, what was the yield last year? So you want to go back and find what it was the previous year. So again, we find for 1%, which is 50,000 divided by 125. And 100% would be 50,000 over 125 times 100. And that will give you 40,000. So again, this showed an increase of 25%, which means it's now has the value of 125%, because the original would have had 100% in value. If you increase that by 25, it becomes 125%. We find here for 1% by dividing by 125, and we multiply this result by 100 to get 100%, which is equivalent to 40,000 tons. Thanks for watching this video. My name is Alistair. Please like, follow and subscribe for more videos like this. Bye. Hi, welcome to Harris Maths. Here are a few questions based on fractions, percentages and decimals. First, we're asked to write 30% as a fraction. So if we have 30% as a fraction, the percentage sign means out of 100. So this is identical to saying 30 over 100. If we divide the top and the bottom by 10, we'll have 3 over 10. And this is the simplest form of the fraction that represents 30%. Next, we're asked to write 2/5 as a decimal. Well, this line here means to divide. So this is actually saying 2 divided by 5, and to write it as a decimal. You might be able to memorize some of these, but this is how you do it if you have to calculate it and show you're working. So we have 5 out here, and we're dividing 2 by 5. The numerator is divided by the denominator. So we ask ourselves, how many 5s are there in 2? There are none. We put a decimal point here and a decimal point, because now we're moving from the singles column now to the tenths. We have a remainder of 2. So now we ask ourselves, how many 5s are there in 20? There are 4. And we know when we subtract 20 from that, we end up with 0. So our answer is 2/5 written as a decimal is equivalent to 0.4. Next, we're asked to write 7/10 as a percentage. Well, if you have a fraction, in order to convert it to a percentage, we need to multiply by 100. So that's 7 over 10 multiplied by 100%. If we divide across in this direction by 10, we have 10 into 10 is 1, and 10 into 100 is 10. That gives us 70%. Here's a question. In a school, 2/5 of the children wear glasses. What fraction of the children do not wear glasses? Well, if 2/5 wear glasses, it's always part of a whole. So the remainder to a whole will be the ones who do not wear glasses. And we know a whole is 5/5. So if 2/5 wear glasses, 2/5 taken away from 5/5 will leave us with 3/5. and 3/5 of the people do not wear glasses. Next, what percentage of the children do not wear glasses? In our previous problem, we had a fraction. If we have a fraction and we want to convert this to a percentage, we need to multiply by 100%. We divide in this direction by 5. 5 into 5 is 1. 5 into 100 is 20. 23 is 60%. So 3/5 do not wear glasses, and that's equivalent to 60% of the class. Number 17, there are 30 sweets in a bag. 20 sweets are red. What fraction of the sweets are red? Well, 20 out of the total of 30 sweets in the bag are red. So this is the fraction, but it's not in a simplified form, in the simplest form. So we need to simplify this. To make it, we divide both top and bottom by 10. Maybe we cross off that. And we're left with 2/3. So 2/3 of the sweets are red. Number 19, in a town in Cornwall, it rained for 13 days during April. What fraction of the days in the month did it rain? Well, in April, there are 30 days. And if 13 of those days it rained, then the fraction of days that it rained would be 13 out of 30. We cannot simplify this fraction because there are no common factors other than 1 of 13 and 30. So the fraction of days in the month that it rained is 13 over 30. Number 20. During the day, Madeline slept for 6 hours. What percentage of the day is Madeline awake? She slept for 6 hours, and we know that there are 24 hours in the day. Then we know that she was awake for 24 take away 6, which is 18 hours. And what percentage of the day is Madeline awake? Well, she's awake for 18 hours. And that's 18 out of the total day, which is 24 hours. But again, we need to simplify this. We'll divide by the common factor of 6. 6 into 24, 6 4s, 6 into 18, 6 3s. So she's awake for 3/4 of the day. And now we need to convert this fraction to a percentage. As before, to convert a fraction to a percentage, we multiply by 100%. We'll divide in this direction. 4 into 4 is 1, and 4 into 100 is 25. 25 3s are 75. So Madeline is awake for 75% of the day. Number 21, Danny scored 9 out of 10 in a quiz. Just by looking at this, we know that he did very well. What percentage of the questions did Danny answer correctly? Well, 9 out of 10, that's how it's written, 9 out of a total of 10 questions. To convert this fraction to a percentage, we multiply by 100%. We divide in this direction by 10. 10 into 10 is 1. 10 into 100 is 10. 10 9s, 90%. So Danny answered 90% of the questions correctly. Write 17% as a fraction. Percentage means out of 100, so this is the same as saying 17 out of 100. So 17 out of 100. We cannot simplify this fraction anymore because 17 is a prime number and only has one common factor of 1 between itself and 100. So we can't simplify this. Next, write 7/20 as a percentage. To convert a fraction to a percentage, we multiply by 100% times 100%. We divide in this direction by 20. 20 into 20 is 1, 20 into 100 is 5, 7 5s are 35. So if you had a test and you got 7 out of 20, you would have had 35%. Write 14/25 as a percentage. Again, we multiply this by 100%. Divide in this direction by 25 to give us 1 here and 4 here. 14 4s are 56. Write 1/8 as a decimal. Well, this, as I mentioned early on, means 1 divided by 8. So 1 divided by 8. How many 8s are there in 1? And none. We had a decimal point here and 1 here, and we had 0. How many 8s are there in 10? There is 1. And we have a remainder of 2. So we add another 0 here, and we have the 2 as the remainder there. How many 8s are there in 16? There are 2. 8 2s are 16, and we have a remainder of 4. We add another 0, and we put the 4 just above here. How many 8s are there in 40? 8 5s are 40. We have no remainders. So 1/8 as a decimal is equivalent to 0.125. And that's it on decimals, fractions and percentages.